Let us look at question number 1 on the second law of thermodynamics. The question says, a reversible heat engine operates between two temperature limits of 600 degrees Celsius and 40 degrees Celsius. The engine drives a reversible refrigerator which operates between 40 and minus 20 degrees Celsius. The heat transfer to the heat engine is 2000 kilojoules and the net work output of the combined engine refrigerator plant is 360 kilojoules. We need to find the first part, the heat transfer to the refrigerant and the net heat transfer to the reservoir at 40 degrees Celsius. And the second part is, let's reconsider part A. We have to find out whatever we found out in part A again, considering or given that the efficiency of heat engine and the COP of the refrigerator are each 40% of their maximum possible values. Now let's do the first thing first, that is write down the given data. Okay, the given data, let us say this is the engine. Now engine operates between two temperature limits. So let us say this is T1 and this is T2. Now T1 is 600 degrees Celsius and let's convert this to kelvins. We get 873 Kelvin. T2, it is 40 degrees and this becomes 313 kelvins. Okay, now this is the refrigerator and this works between 40 and minus 20. This means it is absorbing heat from minus 20 and throwing heat at 40 degrees Celsius. And this is the this is the reservoir at 40 degrees. So T2 is the temperature at which the refrigerator rejects heat. Okay, so this is the same for refrigerator and for the engine, and let us say the heat absorption temperature of a refrigerator is minus 20 degrees Celsius, which is 253 Kelvin. Okay, and the heat, you can say, that is the heat transfer to the engine is 2000 kilojoules. So this is Q1. So Q1 is 2000 kilojoules. Alright, and the net work output of the combined engine refrigerator plant is 360 kilojoules. Okay, so this work that comes as a net work output. Okay, so net work output, which is, this is W1, this is W2, which is the difference between W1 and W2, which is 360 kilojoules, and this is T3. Alright, now given this data and by looking at this diagram, I can straight away find out the efficiency of the heat engine, which is the maximum efficiency is 1 minus T2 by T1, isn't it? So this becomes 1 minus 313 upon 873. Now when you take out your scientific calculators and do the magic, it comes about to be around 64%, which is 0.642. So this is the efficiency, the maximum efficiency of the heat engine. Now how much is the work output of this engine? Let's compare that. So W1 upon Q1 is equal to 0.642, isn't it? And this gives the value of W1, which is 0.642 into 2000 kilojoules, and this would be equal to around 1284 kilojoules. So this is the amount of work that we get from the first heat engine. Okay, now after this, let's find out the maximum COP. So COP max, okay, that is the, you can say, what do you call it, that is the desired effect by the work input. Okay, now if you look at this refrigerator, the amount of heat that is being rejected to the engine is Q2. Let us say the amount of heat rejected to the refrigerator is Q3 and the heat absorbed is Q4. So Q3 becomes Q2 plus, or you can say Q4 plus W2. So this is the the completion of the schematic. Now if you look at the relation of COP, we are concerned with the amount of heat that is being extracted from this reservoir. So it becomes T3 upon the work done. Now work done is a difference of temperature between T2 and T3. So this becomes T2 minus T3. So T3 is 253 upon T2 is 313 minus 253. So this is a value which is 4.22. So the coefficient of performance of this refrigerator is 4.22. Now with this, if you write down the further relation, that is COP is equal to the heat absorbed, that is Q4 upon W2. Now I don't know Q4 and I don't know W2. So how to find out both the values? But I know one thing, I know the net work transfer, that is this relationship. And out of this relationship, I can find out W2 because I know W1, that is 1284. So it becomes W2 is equal to W1 minus 360. So it becomes 1284 minus 360, and the answer of W2 would be 924 kilojoules. So when you know the value of W2, you put this value over here and find out the amount of heat being absorbed. So Q4 becomes 4.22 into W2, which is equal to 3899 kilojoules. So I'm sure you can all do these very simple calculations on your own with your scientific calcs. Now with Q4 known to us and W2 known to us, we can easily find out the value of Q3, isn't it? So let's find that out. So Q3 is equal to Q4 plus W2, which is equal to 3899 plus 924. So the amount of heat being rejected by the refrigerator into the reservoir at T2 is 4823 kilojoules. And if you want to find out the value of Q2, so Q2 is equal to Q1 minus W1. So Q1 was 2000 and this is 1284 and this value is 716 kilojoules. So these are the heat rejection values from refrigerator and from heat engine. Okay. Now if you go back to the question and look at what is to be found out in part A of the question, that is find the heat transfer to the refrigerant and the heat transfer to the reservoir at 40 degrees Celsius. Okay, now if you go back to what we have just found, this is the heat rejection by the refrigerator to the refrigerant, that is 4823 kilojoules. Okay, and Q2 is the amount of heat rejected by the engine to the reservoir at 40 degrees Celsius. Okay, so if you have to find out the value asked in option A, there will be Q3 plus Q2, which is 4823 plus 716, and this is equal to 5539 kilojoules. Right, now I hope you understood the part A of this. Now let's go to the part B of this question and let's revisit the question for a moment. It says, reconsider A, given that the efficiency of heat engine and the COP of refrigerator is 40% of their maximum possible values. Now the maximum possible efficiency is 64% and the maximum possible COP is 4.22. This means that the efficiency of the actual heat engine cycle, because this is a maximum value, the efficiency, or let's write it down like this, the efficiency of the actual heat engine cycle is 40% of the maximum value, and this is equal to you can write down this as 0.4 into 0.642. okay, now if you find out what is the amount of actual work done, so that is W1 actual, so that is 0.4 into 0.642 into the amount of heat being absorbed, that is 2000, it remains the same, and this is equal to 513.6 kilojoules. So this is the actual amount of work done by the heat engine W1. okay, now this would change the value of W2 as well, because W1 minus W2 is given to us as 360. Now let's put in the value of W1 and find out W2, and this would be W2 as 513.6 minus 360, and this would be equal to 153.6 kilojoules. So there is a huge reduction in the value of W2 as well, from 924 to 154 almost. okay, now with the actual efficiency here, let's find out the actual COP also. So actual COP is the 40% value of the maximum COP, which was 4.22, isn't it? So this becomes 0.4 into 4.22. alright, so this becomes equal to 1.69. so this is the new COP, 1.69. alright, now after this let's find out the value of Q4, because we know the value of W2 actual. So the actual amount of heat being absorbed, that is Q4 actual, this is equal to COP actual, okay, into the new value of W2. So this would be 1.69 into the value of W2 was 153.6, and this gives the value of actual heat absorption as around 260 kilojoules. So if you look at the difference, Q4 in the earlier part was, look at this value, 3899 kilojoules, but now at 40% of operating performance, you only have 260 kilojoules of heat being absorbed from the T3 reservoir. Now this gives the value of Q3 actual as equal to Q4 actual plus W2 actual. okay, so you just put in the values and get the value of Q3, and that would be 260 plus W2 is how much? 153.6 kilojoules, and this will give you around 413 kilojoules. Let's just take this value. okay, now we know the amount of heat being rejected by the refrigerator into the reservoir at 40 degrees Celsius, and now I can find out the actual heat rejection from the heat engine, that is Q1 minus W1 actual. okay, so this would be equal to 2000 minus the actual work done is 513.6, and this would be equal to 1486.4 kilojoules. So if you compare this value with the previous thing, if you look at this, the amount of heat being rejected at the maximum efficiency was around 700 kilojoules, but now if you look at the 40, if you are only operating at 40% efficiency, the value, the amount of heat being rejected it is almost, you can say, more than 2 times the amount of heat that was being rejected, at the maximum efficiency. So a very small amount of work is being produced. Okay. And now let's find out the same thing, that is Q3 actual plus Q2 actual. So this becomes equal to 1486.4 plus 413, and this comes out to be around 1900 kilojoule. So this is the amount of heat that is being thrown out in the 40 degrees Celsius reservoir. Now I hope you understood this question. It was quite a lengthy question, but not a very difficult one. The key to this question was to understand the statement of the question, and if you were able to convert this bigger statement into this tiny looking diagram, life would become suddenly very easy for you, because this diagram is the key to getting all these calculations and all these values so easily. Okay, so the first point, read the question, try and make a diagram. If diagram is there, write down the given values and then proceed as your concepts are taught. Now, this was question number 1. I hope you understood this question. Now let's move on to question number 2.